conduct webinars starting today through Facebook exclusively. But that being said, as always, the recordings will be available on our YouTube channel, Thinking Sound, upon conclusion of today's meeting. So I'm very much looking forward to today's topic. And that means that I'm going to share my screen without further ado. And let's start doing this. So as I mentioned before, today the webinar will be hosted to our primary channel as of today, which is the Facebook user community group, the Meyer user community group on Facebook. And that means that you're joining us live as we speak. And we're very happy that there are so many of you. The Facebook group is growing at a steady pace, currently counting over 8,950 members. Thank you very much. We encourage you to ask questions, as always, and we would like you to do so by placing your question in the comments of the video feed on Facebook. So, as you're watching today's webinar, there is the possibility to comment, and I will keep track of those comments and then pose your questions to the panel members at the end of the webinar. And that means that we have another chapter that evolves around the precision toolset, which is our turnkey solution all the way from design to deployment, our turnkey solution for supporting the loudspeaker products. And that means that in today's case study, we get to see again the application of the precision toolset. And today's case study is the Austria Center in Vienna. We have many guest lectures, so without further ado, please allow me to introduce, starting with my co-host. Dennis, are you with us?
Yes, I'm here.
Thank you, Dennis. Dennis Tholema, Technical Service Manager International and fellow Meyer Sound colleague. Thank you for joining us, Dennis. As well as Michael Pohl, also of Technical Services. Michael, are you with us?
Hello, everyone.
Thank you. Thank you for confirming. Happy that you're here, guys. You also brought some guest lecturers, namely Manfred Prochazka, who is the CEO of ATEC Pro, our Austrian distributor. Welcome to you, Manfred. Are you with us?
Hello. Well, greetings from Austria and happy to be here. Thank you.
Thank you, Manfred. And then the people that actually work at the Austria Center in Vienna, which is Ronald Wittenberg, Department Head of Event Technicians. Are you with us, Ronald?
Hello, everybody. Thank you for the invitation to this event.
Thank you very much. Thank you for joining us, as well as your colleague, Karsten Elsner, who is sound engineer at the Austria Center in Vienna. Karsten, are you also with us?
Hi there. Nice to be with you.
Excellent. Well, that means that we can start having our roundtable. The case study means that I'm going to cancel the spotlight on me so that every time when you speak, we also see you. And let's start with a brief introduction of the venue. Now, Vienna is not in Australia, so I think it's important that we make that clear, that this is a very important venue in the heart of Europe. So who would like to talk a little bit about the purpose and the facilities and the application of this truly unique building?
Yeah, maybe I take over at this place.
Be our guest.
So the Austria Center Vienna was originally designed and planned for the UN. That's our neighbor. It was designed as a conference center for the UN, but then they got their own smaller conference center, and the Austria Center was took over and have. Today we have more or less a lot of international medical congresses in there. This is our main business we have there, but we also have a lot of company events. It's all for bigger congresses. Our biggest congress for the European Society of Radiology has about 15 to 20,000 visitors we have in there. We have about 24 lecture rooms and about 180 breakout rooms. So it's a very big building with a lot of space in there. But we have a very small group of permanent employees. We have just 5 audio engineers, 3 light technicians, and 3 stage techs. And we have to handle a lot of business in there. And our main reason why we are here is We have a new sound system installed last year because the old sound system was about more or less 30 years old. And I took over at 2016. And I worked in the Austria Center also, I think, 25 years ago as an audio engineer. And when I returned 2016, I entered the main hall and said, whoa, they still have the same system they had 25 years ago. And it's still working. So it was a good system, but it was a little overaged, I think.
Right.
So that was the reason why we changed it, and we started with a tendering procedure, and we want to get a new system. And this is the point where Manfred can tell us a few things.
I want to start a little bit earlier. In 2016, when you first started working at the Austria Center, it was also a time where the Austria Center was building some new small rooms. And you came to me and you were asking for small, self-powered, high-quality speakers for those rooms. And I showed you to the UPM 1P at that time, and you was really amazed about it. And well, the first deal that we made with Meyer Sound and the Austria Center was a bunch of UPM for, I think, I don't know, maybe 6 rooms or something like that. And this was, let's say, the first time Meyer Sound loudspeakers went into the Austria Center. And from that time, I think you made more and more rooms with Meyer Sound, with UPMs. Then I think you bought the first linear system, and at the end of 2018, you came to us because I hope, or it seems like you were really satisfied with the quality of the Meyer Sound loudspeakers, and you were asking us for a design for the large room, the bigger halls. And yeah, that's when we took over, make designs, made the first map files, and then there was the tender. And yeah, at the end, luckily we won the tender, and now I think we have a lot of Meyer Sound speakers in the Austria Center. It's, I think, something around 230 speakers. And maybe, Michael, you want to tell us a little bit more about the objectives that was given in the tender and about the solution, what we did.
Absolutely. Thank you, Manfred. So when ATEC was requested to offer a design or to come up with solutions for the big room, Manfred reached out to the Meyer Sound technical services team to help with designing the system and just scaling the system properly to meet the requirements that was very precisely made from a consultant company in cooperation or in close cooperation with the Austria Center. And as you can see in this slide, it's very different parameters that the system had to meet. So the SDI and all places in the room had to be greater than 0.6. SDI stands for Speech Transmission Index, but we will come to this a little later. And the SPL variations, A-weighted, should be smaller than 10 dB all over the place. The same for C-weighted SPL. The SPL target from 100 Hertz to 8 kilohertz should be within plus minus 3 dB. And the maximum SPL measured at the front of house, which usually is between 30 and 40 meters away from the edge of the stage, should be continuously A-weighted 96 dB and peak 106, which is quite something, to be honest. What was also very important was the base ratio, which is an indicator of the ratio between your high mids or low mid and high frequencies and the amount of sub energy, which 0.9 to 1 means very flat, which also is a very big indicator that you don't need too much sub energy in the room, which I think is absolutely caused by the main purpose of the venue, which is conferences, congresses, and presentations and this kind of stuff. And I think for speech and this kind of stuff, you don't need plus 20 dB in the headroom in the subs, so to say. So after ATEC and especially Manfred reached out to us at Meyer Sound Technical Services, we built a team that was working on the design. This team was led by Dennis, and I came on board a little later to help also demoing the system, because that was another requirement from the Austria Center and the independent consultant company, that the system had to be shown. And what was very interesting is that the system was only measured, and no real subjective listening took place to judge if the system is nice or appropriate or overscaled, underscaled, whatever you want to say. So there was a lot of measurement positions where this consultant company took measurements for all these parameters that we just saw in the previous slide. And different manufacturers and companies have been invited to present their designs and their systems. So the total system in the room comprises 3 main arrays of LINAs. The left and right arrays, as you can see on the picture, is columns of 13 LINA systems. The center fill comprises 6 LINAs, and there is 2 additional arrays with 6 LINAs. We have a couple of flown 750 LFC subwoofers, and the delay arrays also comprises a flown sub on top. There is a couple of fill systems also being used, and also a monitoring system for the stage, which is very close position to the main PA, but of course facing the other way around and covering the stage. One of the very important points also for the center is that the processing for all those systems had to be a real network processing, which we solved with our Galaxy 816 network platform. And we are running AVB there. That's also enables the AV center and the text to feed signals into the system on every Galaxy and share those signals with all the other ones. And that makes the system very flexible and gives the system lots of inputs. If you just imagine that each Galaxy 816 can receive 8 physical analog or AES signals. Well, AES, it's actually 4 cables, but 2 channels each. So 8 physical signals. And with 4 Galaxies, there's quite some channels that you can get into the system. But let's dive a little deeper into the design and let's check what it is. On the right-hand side, you see a picture of this room, and it doesn't look that big, but it is. On the left-hand side, you see a screenshot out of MapXT, which we used to make the actual design. And from the edge of the stage, which is where you can see the yellow dots or the yellow points with the front fills, exactly there, to the end of the room over there, it's around 56 to 60 meters. It depends a little because the stage can be coming in different sizes. So it's sometimes it's not as deep as you see right now. I think that's the maximum depth of the stage. So the throw of the system varies a little in regards to the fill systems. The main PA, of course, is on fixed positions. So the picture is taken from one of the very, very last seats in the very last rows. So we are looking now to the back of the stage with 65 to almost 70 meters. But let's take a closer look to the positions of the systems and the main purpose there. Let's begin with the center, which is comprising 6 linas. This center is not a real center as you would name it in a musical or theatrical world. So the center is not covering the whole venue and all the seats. It is a center fill to actually close the gap between the left and right systems. The center cluster is tilted pretty much downward, as we can see in the next slide here, to literally fulfill the requirements of making a nice transition from the very left to the very right and filling that gap there. If you want to fly a line array with this much down tilt, it takes some rigging efforts to achieve this. So we have a pullback frame that is installed on the lower or on the lowest cabinet, which is then brought up to another pick point on top of the truss, as you can see in the picture. In the next slide, we will see the main left and right linear arrays, which I already mentioned, uses 13 elements each side, which is still a pretty small system. What is interesting is that those systems are slightly turned outwards, so they're not 100% straight. Just also to cover the outer areas, as you saw on the first one, the room is what we called fan-shaped. So it opens up and it widens up more and more if you get more away from the stage. Just to make sure that the coverage also meets the very outsides and the outer seats, those systems are not 100% straight. But also very important is that the transition between the left, center, and the right system is very smooth. And we took a lot of efforts to make this transition as invisible, or well, it's inhearable if this is a word. So as smooth as possible so that you don't spot when you move from one system into the other. But of course, yes.
I also have to mention that basically the position of the left, center, and right was a given fact. There was a trim level that was desired because they have some gigs in there, some shows, some productions where they have a big video projection screen in the back of the stage that basically defined the left and right position of the main array and also defined the trim height of the center and all speakers that are basically suspended by the truss, so that at no point any speakers throws a shadow on the video projection. So that was one interesting thing.
Right, not just line of sound, but also line of sight.
Correct.
Yeah.
Important.
I almost forgot about this one. For me, it's still audio first. Sorry for that. But thanks for adding that, Dennis. Of course, that was a very important point to make that. As we've seen on the pictures before, of course, a couple of subwoofers are deployed because you want to have a linear frequency response all the way down to 35 around. In the design, we achieved this with 3 750 LFCs in a gradient cardioid array. A little bit spaced left and right out of the center, which was also given by the loading weight and the loading capacities of the main truss. But of course, you want to keep the stage clean, and you don't want to have disturbance on stage just by some low end that you spill there. So that's why we decided to go for gradient arrays in this way, as you can see here. On the next slide, you see the 6 UPM1P front fill systems, which are covering the very first 2 to 3 rows in the venue. Because as you can see, the main array and the center are actually placed above the audience area, not above the stage. And as Dennis mentioned, those positions have been given. So a front fill system is very important. And what is also a very important point is that the fill systems that are filling those gaps are having the same sonic signature and the same phase and frequency response. So you smoothly blend over from the fills into the main systems without any disturbance and stuff like this. So as we will see a little later, this also could be read in the measurements from the consultant company that this transition is really good and that the phase responses of all those speakers are matching, which we also achieved, of course, using the tools within our Galaxy network platform. For example, the product integration for those systems to marry them all together, so to say. For the outer sides, we also wanted to have a little stronger system because, as you can see, the audience area is also not straight in front of the stage to the outsides. It gets a little closer towards the rear wall because the stage has a, I don't know, is it still trapezoidic, but yeah, it's a multi-edge stage. So for those applications, we decided for the Ultra X40s because of their wide coverage, so we can also anchor the signals also closer towards the stage. You don't want to sit in the second row and see a presenter 4 or 5 meters away from you and hear him coming out of the roof. That's not very nice, and that also is very distracting in regards to concentration if you want to listen to a congress and stuff like this. And those events can take a long time. So that was also a very important part for us to bring the image, so to say, down to the stage.
No shower sound.
Yes, absolutely. That's what it is. And also those Ultra X40s, I'd like to mention, I think, Manfred, correct me if that's wrong, but I think that was the very first Ultra X40s installed in a venue worldwide.
Absolutely. The first, as I heard, not the first delivered, but the first installed X40s worldwide.
Yeah, thank you. Yes, on the next slide, we will see the positions of the delays, which is around 34, 35 meters away from the main arrays, but the actual coverage starts like 40 to 45 meters away from there. So we actually think about those systems more as a relay system than a delay system, which we will see when we are coming into the section view. As we mentioned before, those systems have a flown subwoofer along with it because you also want to fresh up the low frequency energy a little bit, which is just in the nature of the systems and the wavelength. With the long arrays, well, 13 Linas, that's a pretty long array, and that causes that you have control almost all over their full frequency response, which means you can shoot the energy pretty straight where you want them. But the subwoofers are not showing this very directive or directional pattern, so you lose a little more energy over distance, and that's why we decided to go for some subwoofers in the delays as well, and that works pretty well. And Sounds pretty nice. As we said before, everything is controlled, and the sound is distributed by Galaxy 816 network system, where 3 of those galaxies are installed in the roof in a tech space, and also you can see on this picture the RM server, which is our remote monitoring system to monitor the loudspeakers, and which gives us very detailed information about the temperature of the heat sinks, the wattage, the power supplies, the drivers itself. It's very, very intense, and we get a lot of information how the system behaves, and if the system is still in a good state, and this kind of stuff. The fourth.
And not only that, the other option that you could do with the RM server connected to your loudspeakers is mute all speakers when there is, for example, an emergency announcement. So,
Right, the
Yeah.
override for voice
Yeah.
voice evacuation message.
Absolutely. As you can see on this picture, Merlijn, can you go back one slide, please?
Sure.
You also see this purple network switch, which is an extreme switch, which is an AVB-enabled device and an AVB-certified switch, which we are using to connect the galaxies in the AVB network. And the fourth galaxy is placed at the front of house system, or at the front of house rack. So you can easily also add more signals there and patch the mixing desk directly into the system, and the connections in between those positions is made by fiber optics, if I'm not mistaken, but I think we can actually also see this on the picture, that there are fiber connectors visible there. But let's take a closer look into the actual positioning and curving and aim and splay of the systems. As we said, see, there is a typo. The main array is, of course, 13 LINAs and not 6 LINAs, excuse me. But you see that this system is aimed to cover the first 40-45 meters of the venue. And then at this position, the delay array is taking over. But as you can see, they don't overlap really. It's a very, very small space where they actually just share the space. And as you can see here, that's why we actually call this more like a relay system instead of a delay system, because you don't really want to fresh up the signal there. You really literally taking over, and you know, you have a special PA for the rear of the venue. In the next slides, we will see some predictions through a couple of octaves, just that you can see what the system is performing about. Here we are in a 125 Hertz octave with 1 octave bandwidth, and each color represents from red to blue 3 dB attenuation of SPL. But from the very top or from the very front of the venue all the way to the back, we have variations of around plus minus 3 dB, even in the low mids, which is very, very nice and not very easy achievable. But since we are actually deploying our tool sets, which includes the LMBC, the low mid beam control, we could literally also trim the system that even the low mids are following the highs very, very similarly, and the frequency response is very, very nice and very equal all over the place. And the next octave, you can see pretty similar results. We're now at 250 Hertz with the same bandwidth and the same stuff. And you see it's very smooth. It's slight variations that we have. And just for those that are not that familiar with map, if you see this edge of a 3 dB thing, that doesn't mean that you literally at this point are 3 dB lower in level, but at one point map has to make the threshold between, for example, these yellow-green to the greenish color or the cyan color. So it might be just a dB or 1.5 there, but it's very, very even, even at those low mid frequencies, and that's pretty unique, and but also very important in this kind of a room, because you want to really control also your low mids to not create too much reflections and too much reverberation, because if you've seen on the picture, this room is big and has a lot of reflective wooden walls, and you want to also keep the low mid energy or concentrate the low mid energy where you want to have them, not shooting it into the roof and on spaces where you actually don't need it. The whole thing continues over 500 hertz, and it looks pretty similar at 1K as well as 2K, 4K, and also even 8K, where it's very, very stable and very similar, as you can see. Well, in map, we already wanted to see the distribution and the differences in the frequency responses from the very front to the very back, because as you've seen, there was a lot of requirements, and those requirements are pretty strict and have small tolerances. And within the design process, we already wanted to make sure that the system fulfills all those requirements. And as you can see here, from the very front to the very rear, that the variations are very, very small, and that the frequency responses, or the amplitude response as we see here, is very similar all over those places. So after the system has been installed, and we're not talking about the final installation, we're talking about the demo at the moment. So the Austria Center conducted those demos with different manufacturers, but each system was in for 1 day. So we had installed it in the morning and presented a little later. Each system was measured and checked in regards to the requirements of the Austria Center, and of course, each system engineer or team of system engineers measured their own systems, and we of course also want to share those measurement data. So
important. You know, everybody had the same condition, so there was no argument about speaker locations. For example, if you have 3 competitors demoing speakers in the same room, but they all want to use the same location for the speakers, is just not possible. So Austria Center made that decision to invite the different competitors on different days, so everybody has the same condition. So it's a fair demo for everybody.
yeah, absolutely. The traces that you can see here now are actually the traces from the final calibration, but they are very similar to what we had in the demo. Otherwise, I think we wouldn't have won that pitch. But you see, that's real life measurements taken with a SIM3 measurement tool, our own thing. And the variations, of course, are looking a little more strange, or we have a little more zigzags or gaps and little peaks in there as in the predictions, but the predictions are free predictions. And this is the real room. But as you can see, everything is very stable, and it looks very, very similar all the way from the very front, again, to the very back. And just to emphasize this a little more, in the next slide, we are actually comparing those traces. So you see on the top the rear measurements made with SIM3, and on the bottom again you see the measurements made with the virtual measurement tool or the measurement viewer within MapXD, both having the same resolution with 1/48 octave in the vertical scale, so to say, in the frequency range. And also the SPL scale is the same, as you can see here. But as we said before, in the whole procedure of this kind, in the venue, there was made measurements from an independent consultant company, and those measurements need to confirm that the system is fulfilling all these requirements. Merlijn, can you enhance one slide, please?
Sure.
And one of those very important things, especially talking about one of the biggest conference and congress centers in Central Europe, is of course speech intelligibility, and therefore the speech transmission index was one of the most important points to be measured. And Merlijn, do you want to give us a little more detailed information what STI means?
Sure. Well, for starters, the absolute measurement of speech intelligibility is a super complex science. Speech is, of course, a very complex signal. That being said, speech transmission index, also known as STI, is a well-established objective measurement predictor of speech transmission. So it's an indicator. It is an indicator that says if you have a high STI value, then you'll likely have successful speech transmission through your delivery system, which is the sound system, in collaboration with the room. And it's my understanding that part of the requirements was to ensure a speech transmission index of at least 0.6, which in the left-hand chart, which you can find on Wikipedia, puts you in the so-called D category. Notice that in the D category, you're looking at a nominal STI value of 0.62, let's say 0.6. And judging by the comments, this should suffice for good speech intelligibility in lecture theaters, classrooms, and concert halls, like the venue that we're discussing today. And this should suffice for complex messages using familiar words. But if we look at the objective measurement made by the consultant, you will see that very often we manage to get 0.7. And 0.7 is like 1/10 more than 0.6. It's a 10% difference, if you will, but it's the difference between a D category rating and a B category rating. And it's considered a high speech intelligibility rather than a good speech intelligibility, suitable for theaters, auditoria, parliaments, assistive hearing systems, and more. And in terms of messaging, what has changed between the D and the B category is that the B category also allows you to transmit complex messages using unfamiliar words, which of course in a location like this, where you have an international usage of the venue and foreign languages being spoken, of course a lot of words might end up being unfamiliar. So having that real high speech intelligibility is mission critical in such an application. And an objective consultant, Toonarchitectuur, has made the measurements of the existing system at the time, as well as of all the systems that were demoed, which led to the following values. And if you look into the matter, it's actually an IEC standard, an International Electronics Consortium standard. These values turned out to be the same for both male as well as female speech. And the value that was requested was 0.6 or more. And if you look at the previous system that Ronald talked about at the beginning of the presentation, then we have values that are actually less than 0.6, depending on where you are in the audience. So what I found interesting first time that I saw this chart is that specifically in the second half of the auditorium, where we have our sectors E through F, things have improved considerably. We went up from 0.5 to 0.6, which is of course the virtue of the delay system that Michael talked about earlier during today's webinar. Well, I should say relay system. It's relaying the message rather than delaying the message. And you can also see the payoff of using the Ultra X40 as infill, because this sector in the audience, which is your A sector, used to be 0.7, but by having the presence of the Ultra X40 in that part of the room, we gained another 10% in terms of speech intelligibility. And this is kind of independent validation. It's an indicator. It's a well-established objective measurement predictor of how likely speech transmission is expected to occur. And that was critical in the decision-making process that led ultimately to the commissioning of this system. Ronald and Karsten, if you have anything to add to my brief explanation, by all means.
I just want to point out the thing why this is so important is, like I mentioned before, most of our congresses are medical congresses. So they are very detailed in what they have to tell their guests, what they have to tell the audience. And so this is very important that they get all the informations out of the keynotes, all the things. And it's also important what Dennis told us before. We have to really take care about the sidelines and things like that. This was the reason why we had to define the points where the PA system, where the speakers, where we could mount them, because of also the presentations. They want to show their scientific presentations, and it's very detailed in all these medical congresses. So this is a very important thing, and we have to really take care about it.
Yeah, thank you. Because as I said earlier today, you know, the absolute measurement of speech intelligibility is a complex science, but surely the improvement was not only measurable, but also audible. Is that something that you already feel comfortable talking about at this point into the webinar? Did the measurement predict improved speech intelligibility? Was it in good agreement with your personal experience?
It definitely did. With the words are way clearer, way better to understand. And yeah, we're pretty happy with that. And so is the feedback I get from the audience.
Excellent. Excellent. Okay, well, that concludes my contribution on STI. And that means that I think that we have a couple of impressions for our viewership to get a sense of scope and scale. And this is also where I invite all panel members, you know, to join me in the round table and just, you know, talk a little bit about what we see in the photos and in relation to everything that we've been discussing so far. So this is another picture of your main auditorium. It's my understanding that there's a secret behind this wall, right? Can you tell a little bit about that?
It's not that wall. It's the wall on the left that you can barely see.
Oh, really? Did I do a polarity reversal? Sorry.
Yeah, kind of. It's just mirrored. No, it's the hall A can be extended with two more rooms that are called room B and C by just removing the walls. It's not just, and I think it's also not going automatically. You have to push them manually. Those modules, yep. You can see them here. So it's actually real work. But you can see this is one room. I think this must be room B or something. So if you take away exactly those walls, it opens up the space and the sideline into room A. So when they have a lot of people, more that could fit in the main hall, they can just open those walls. And those systems installed in B and C can be used as independent systems, so they can have, you know, congresses in 3 different rooms. But as I said, it can be open, and then room B and C become a part of room A. So that's where the Galaxy platform comes into place, and the connection through ABB, because basically all the galaxies for room B and C and A are connected to the same ABB network. So that made it very easy to connect and send audio signals from the main hall into both rooms. And with a different snapshot and a different time alignment that we've done during the tuning process, those rooms, that PA systems for those rooms are 100% integrated into the main room. So that was also one interesting thing about this venue.
So,
and when you're standing in that room, it's totally super difficult to find a horizontal angle of the array, because most of the time when you aim them, you go there and you look at them and you find you try to find a fixed point where you can rotate those speakers around, and in that room it's just nearly impossible, because it's a, what is it, hexagonal. It's, there is no straight 90-degree wall in that place, which made it a challenge too.
Ronald, does it happen very often that you open up these rooms, or is it rare, only once or twice a year?
To be honest, it's more like 1 or twice a year, but yeah, it depends on the Congress, what they need. But most of the time we use the room separately. But another times it's very, very important to have it completely open and have the combination of all 3 rooms together. And what the guys did there, it worked fantastic. And I'm very sad that we don't have the rooms open all the time, because this is the best thing on it. It's really great.
Merlijn, if you advance a couple of slides, there is a picture actually, I think from the preparation of one of the events, this one. Go one back, please. So this is 2 pictures actually taken from, I think, close to the stage. And you can see these elevating seating areas there, and this is exactly where those walls can be opened on those sites.
It's massive.
And, oh yes, it's
massive.
If you see the pictures, you think that's a pretty large room, but if you're in the room, it is really it has that, wow, this is a real big space. And as you can see in this picture here as well, is that the rear section in the middle of the room can be elevated, as you see here. So also the system has to fulfill those requirements, and this can be also flat floor for other situations and stuff like this. And if you advance 1 slide more, please.
Yep, let me clean up my annotation.
Sure. So, and this is actually a view from, I think that's room B through room A into room C, where the walls are open completely. The stage would be to the right-hand side.
And what we really, really good achieved in that is the directional reference to the stage. So you don't, if you are in room C or B, you don't hear the system which is installed in the room. You hear the conductor from the stage or the band playing from the stage, and this is really amazing. So that's, and I think that's mostly Michael's and Dennis' job, because they put a lot of effort in to make this happen, and it's really amazing if you hear that.
Since it's my understanding that the primary purpose is conferences, but based on what Manfred said just now, it sounds like you also have the occasional musical event, or a musical add-on to a conference.
Sure, we have. Since there are things like opening ceremonies, closing ceremonies, and such stuff, we occasionally have music, and the system also had to serve that.
But the main purpose is not concerts, because I think you had a nice experience with a concert a few years ago, where you also had to now play some constructional add-ons on the lower floors to make sure everything is safe. I like that story. Maybe you can talk about that a little bit.
So yeah, it's way before our time, but the whole construction of the building, this room, the main room, has a swinging floor, and if you have dancing people or shaking people, things like that, the whole room, the whole floor starts to move, and it's really heavy moving. And for this event you see here, it's a ball. We have to install special columns in the underneath it in the entrance hall to stabilize this floor, because in the ball the people are dancing, and we have to set up, I think, 10 to 12 columns in the completely entrance hall and in two other halls to get a little bit rid of the shaking floor.
Wow.
Well, that's like bouncing people when you have, let's say, a rock concert or something, where they start pogo and jumping up and down. Is not going to happen in this venue anymore, since that one experience you had in the past.
Yeah, absolutely. They're forbidden in this venue. Yes.
So that's why also the low end requirement wasn't as high as you would normally do for a rock show or a concert. So,
well, I for one,
people tend not to pogo and jump up and down during classical concerts.
Excellent. So besides the main auditorium and the overflow rooms, there's also other rooms in the building. Is that something that you would like to elaborate a little bit about, Ronald?
Karsten, maybe you can take over and tell us a little bit about it.
Oh, yeah, this is actually Hall D. Installed 8 leaners to the left and the right, and these 8 leaners cover the 35 meter of depth. And since we have the UPMs in the ceiling, I don't know if there's a picture of these, we don't even need front fills for this one.
I see. And what do we see over here?
That will be Hall E or F1. It has 2 UX40s in front and 3 UX40s as delay, and pretty much doing everything we need in there. We decided for point sources, since the rooms E1 and E2 can be combined by removing the wall in the middle. So we had to find a solution where these systems can be combined and separated and working as a separate stereo or as a combined stereo.
I see.
And trim height, as you could see, there's another video projection, so a low profile speaker was preferred.
Yes, definitely.
Yes.
Line of sight as usual. Congress venue.
So the rotatable horns are was really helpful here, so that we can mount it horizontal.
Does a job pretty good.
And then I was about to say there's another space within the building.
Yeah, that's the entrance hall. That's what we did this year on emergency, because the old system is broken, and so they need very soon, very, very quick, a new solution. And yeah, it's if you go in this entrance hall, you will think that it's from the audio spot. It's a horrible place with a lot of reflections, and we were really surprised how really nice the Linux system sounds inside, and we had really no issues when we installed it and when we did the setup and everything. It's I think nearly flat. So we put it in first in native mode, and it was the first result was really amazing. And then we made some little tiny EQ corrections, but it's really amazing, because you won't expect when you go in this room that this sound with nearly no reflection is possible inside this.
Right. Excellent. Well, wow, time flew by, like 55 minutes, like zoop, which means that I'm more than happy to spend another 5 minutes for Q&A, starting with one by myself. And meanwhile, those that are joining us on Facebook, please start putting any questions you might have in the comments of the video feed. So Ronald, during the preparation of today's webinar, you mentioned that government funding is involved in a project like this, which was important for the independent validation of the system. Is that something that you would like to elaborate a little bit about, why it's so important to have independent third-party validation?
Sorry, so got it. No, it's important for us to have everything checked, because, like you mentioned, we're more or less owned by the state of Austria, and so it's nice if we say it's great, it's fine, but it's always better to have independent third-party meaning and someone who can prove this. And this is also the reason why we had the, I don't know, in English it's the BBG, it's the Bundesbeschaffungsgesellschaft, for this tender procedure.
Okay.
It's also a state-owned, what's it called?
Department.
Department. They do a lot of tender things for the state itself, and they helped us with all this, and they proved that everything is correct and everything is like the law tells us it has to be. So this is an important thing on it.
So were they also involved in the drafting of the list of requirements? Is this something that your team came up with, or did you have consultants?
This is something my team did, more or less. They just take care that everything is in the what the government wants to have, and what is the regulation and what we have to do. But the definition of the technical things was planned by our audio engineers, more or less. And we just, as a consultant, Peter Wilnsdorfer, who did all the measurements. And we have another consultant. He's more or less involved in all the electrical things in the Austria Center, and he helped us with all the connections and with things like that.
Right. And you also told me that you work a lot with independent contractors, and they are familiar with the situation as it was before, and now they encountered a new situation. And it's my understanding that the response, the feedback has been positive.
Yes,
correct me if
absolutely.
I'm wrong.
Yes, no, absolutely. So the feedback we get from the system is also from the customers. You know, not only guys they're involved in audio and things like that, also from the customers. They really can hear the change and what happened in there. And we got a lot of positive feedback from all the engineers. They're working there, and they're busy for us. Because we have on big congresses, we have about 25 to 30 freelancer working there in all the halls. And they're really happy to have a new system and have new toys and have great toys now.
Excellent. Well, in the meantime, I've been monitoring the Facebook feed, but no questions so far, which leads me to believe that we did a great job at showing this case study of a very impressive facility. Anyone else on the call that wants to comment before we might consider calling it a day?
Yeah, there's one thing that I like to ask actually, since I was involved in the calibration, but I've actually never really was seeing a congress or a show or an event in there. As we see also in this picture, this is the flat floor with a lot of tables and chairs and this kind of stuff. But it can be also completely different, and the rear of the room can be elevated. What is your experiences with the change, the mechanical change of the size of the space, and how does the system handle this? Do you create different snapshots, or did you had to do some adjustments to the room, or is the system serving this in a way that you don't need to touch anything?
Well, usually the elevation in the rear of the room is in for most of the congresses. If it's flat like this, it's for for a test situation like this one is, or for exhibitions where we don't use the system. So we're not really extensively tried it out this way, but it served for the purpose like this. It served pretty well. We didn't do another setup for this or so.
Oh, very good. That's good to hear. But I think Manfred also wanted to comment something.
Yeah, just wanted to mention what is, I think, really fantastic, because you have in the Austria Center from really small room to a very large room with more than capacity for 3,500 people. And we used, well, there is in use more than 230 speakers in the Austria Center from Meyer Sound, and we have only 4 different types of speakers. So we achieved everything with leaner UPMs, 750 LFCs, and the new X40s. And I think that's something very special, which for Meyer Sound. And it's also that, you know, the UPM 1P is something like 20 years old, and the leaner is a quite new system, and the matches together. So I think that was also one of the points why Ronnie decided, or the Austria Center decided to go for Meyer Sound, because we have, you know, there are not a variety of hundreds of different speakers doing different jobs, so you can use every speaker in any room. In the small rooms, we have the UP1s as main PA. In the large rooms, it's monitoring or front fills. So I think that's something to mention about.
Yeah, it sounds like your Swiss Army knife that serves a lot of purposes. Yeah.
Yes,
Excellent.
it does.
Yes, it does. Thank you, Karsten. Okay, well, unless anyone has anything to add to today's webinar, and Facebook still doesn't show any questions, I'm slowly going to proceed by thanking today's guest lecturers, starting with Karsten Elsner, sound engineer at the Austria Center in Vienna. Thank you very much for joining us today, Karsten.
Thanks for having me.
And same goes for Ronald Wittenberg, also from the Austria Center in Vienna, department head of the event technicians. Thank you for elaborating on this wonderful collaboration.
Thank you very much.
And of course, I would also like to thank my fellow Meyer Sound colleagues, starting almost there. Sorry, I'm running ahead of myself. None of this would be possible without our Austrian distributor, ATEC Pro. So thank you, Manfred, CEO of ATEC Pro, for liaising in this regard. Much appreciated.
Thank you very much.
And now I get to say, I would also like to thank my fellow Meyer Sound colleagues, Michael Pohl, Technical Services, as well as Dennis Tholema, Technical Service Managers International. Much appreciated for joining us today. And that means that Oh, thank you. Thank you. And that means that, as always, a recording of today's webinar will be available on our Thinking Sound YouTube channel within the next couple of hours or so. And as for the remainder of this week, on Friday, we're going to do a very large house of worship. To be more specific, we're going to do a case study of the Gateway Church. So that's going to be super interesting. Be sure to join us this Friday, where you can watch, as of today, can watch the live webinar exclusively through our primary channel, which is, as of today, is the Facebook user community, the Meyer Sound user community on Facebook. Next Monday, we'll start, due to popular demand, we'll start with doing a live rerun of a previous webinar. We've talked about MapXT for 3 weeks in a row now, and that means that we have all our ducks in a row and are ready to talk about Ultra Series, the X40 that Manfred mentioned earlier today. We're going to talk about the application of Ultra Series, starting in a very small venue, such as a bar or a club, and how to use map to design for such an environment. And that means that, without further ado, thank you again to today's guests. Thank you for being here. And as for you out there, our viewership, please stay safe, please stay healthy, and best to your loved ones. See you next Friday, this Friday. See you this Friday. Bye-bye.